In this video, we'll be looking at linear expansivity and its application. So, what is linear expansivity? Linear expansivity is also called the coefficient of linear expansion. So that's another name for linear expansivity. It is also called the coefficient of linear expansion. So linear expansivity, also known as the coefficient of linear expansion, is the change in length. The change in length per unit length per degree rise in temperature. This is what linear expansivity is all about, or coefficient of linear expansion. So again, linear expansivity or the coefficient of linear expansion can be defined as the change in length per unit length per degree rise in temperature. And this formula depicts what we've just defined. Linear expansivity alpha is equal to the change in length, which is this delta L, per unit length over L1 per degree rise in temperature, which is the change in temperature delta theta. So this is what linear expansivity is all about. Linear expansivity of a substance is the change in length per unit length per degree rise in temperature. So let's look at the application of linear expansivity. So one thing you should know here is that when a body is heated, it expands. If you heat a body, it will expand, it will increase in size. And when it cools, if you cool it, it contracts. It will contract. So this is very important. When a body is heated, for example, if I heat iron, it will expand, it will increase in size, it will expand. And when I cool that same iron that I heated, it will contract. It will reduce in size. This is why it is advisable to buy a pair of shoes when the weather is hot. So when the weather is hot, your body will expand. It is natural. And when the weather is cool, very cold, your body will contract. The size of your body will contract. So this is very important. So what are the applications of linear expansivity? Where do they apply? Where do we use them? So the knowledge of linear expansivity, they are used in construction of railway tracks. They are used in construction of bridges and expansion joints, in pipes, in metal pipes and overhead cables, in bimetallic strips in thermostats. Then they are also used in glass and ceramics in cooking utensils, in making glass and ceramics in cooking utensils. So these are the various areas in which the knowledge of linear expansivity applies, and we're going to look at each of them. So the very first one, which is railway tracks. Linear expansivity, the knowledge of it is applied in construction of railway tracks. So how is this, or what is it about? During the construction of railway tracks, gaps are left between rails. If you look at this, you will see this gap here. There is a gap here. This is the gap, the extension gap that is left between rails, between one rail and the other. So what is the essence of this extension gap that is being made during the construction of railway tracks? So this gap is to allow expansion in hot weather. It is to allow for expansion in hot weather to prevent buckling. So in a situation whereby these gaps are not made, or these gaps are not put in place, these extension gaps are not put in place, what will happen is buckling. When the weather becomes very hot, the rail will begin to expand. So because of the fact that it cannot accommodate that expansion, there is no extension gaps, there is no place to accommodate that extension or that expansion, the rail will begin to buckle. It will begin to bend as it is depicted here. So this bending of this rail is what is referred to as buckling. So this is very important. In the construction of railway tracks, extension gaps are left between the rails, and I've shown you an example here of an extension gap that is left between the rails. And the reason is to prevent buckling during expansion in hot weather. So this is very important. So you can be asked a question that what is the essence of applying linear expansivity in the construction of railway tracks? So I've already taught you that. It's very simple. The reason is to prevent buckling, and structural damage due to temperature changes. So, like I said, when the weather is very hot, this extension gap will accommodate the expansion of the rails. But in a situation whereby it is not in place, buckling will result. That is the bending of the rails. So let's dash to the next area where linear expansivity applies. It also applies in construction of bridges and expansion joints. So in construction of bridges, expansion joints are usually put in place. You can see this part here, this space here. This is an expansion joint. 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 When you get to a bridge, just come down and look at the bridge very well. You will see all these expansion joints. They are not closed, they are open. So these expansion joints, they allow for expansion and contraction due to temperature change. When the weather becomes very hot, they will expand, and when the weather becomes cool, they will contract. So these expansion joints, these gaps, they help to accommodate any form of expansion when the temperature of the environment becomes very hot. So these are expansion joints. These are expansion joints. They help to accommodate expansion when the temperature of the environment becomes very hot. So the essence of this, of putting this expansion joint in place, is just to prevent any form of structural damage to the bridge so that the bridge can last long. This is very simple. So let's look at the next application in metal pipes and overhead cables. So allowances are usually made when fixing overhead cables. So the reason is to prevent what is called sagging. And the answer for this is to make these structures last longer. So we still have another application in bimetallic strips in thermostats. So linear expansivity also applies in bimetallic strips in thermostat. So the bimetallic strip, it's a strip that is made up of two different metals, and that is why it is bimetallic. It's a strip that is made up of two different metals of different expansivity. So when this strip, this thermostat, is subjected to heat, when it is subjected to heat, the brass has a higher linear expansivity than steel, and so brass will expand more than steel. So when it is subjected to heat, the brass, which will expand more, will begin to bend over the steel. And also when it is cooled, the brass, which has a higher linear expansivity, will begin to also contract more than the steel. And that is why you have it like this. So the essence for this is to activate the switch in the thermostat. Because of that difference in expansivity and the difference in how they expand, that will activate the switch in thermostat. The bimetallic strips is also used in fire alarms to detect heat and trigger the alarm. So the other application of linear expansivity that we have is in cooking utensils. So glass and ceramics, they are usually used in combination with other metals like copper, like steel, like aluminium, in making cooking utensils. And this is to help them to be able to withstand that expansion. So with this, we come to the end of linear expansivity and its application.